Good day, grade 12 learners. So today we are going to learn about quadratic functions, which fall under the topic functions. What you need to know by the end of the lesson is the definition of a quadratic function, equation and properties of a quadratic function, intercepts, axis of symmetry and the turning point, transformations of a quadratic function, and domain and range.
In this video, we will be focusing on the quadratic function, which is a subtopic that falls under the main topic, functions. We will be looking at the definition of a quadratic function, the equation of a quadratic function, as well as the properties of a quadratic function, such as the shape of the graph, the intercepts, the axis of symmetry, as well as the turning point. Now, firstly, we need to ask ourselves, what is a quadratic function? And with this definition that I have here, it says that a quadratic function is any function defined by a polynomial whose greatest exponent is 2. Now we have two types of equations we deal with here when we deal with quadratic functions. The first one is the general formula, the written f of x equals to ax squared plus bx plus c. And the second one is the standard form, written f of x equals to a open bracket x minus h close bracket all squared plus k. Now looking at both the formulas, we can see that the greatest exponent of each polynomial in this case is equals to 2.
Moving on, we are going to be looking at transformations. So under transformation we have shift and reflection. So for shift, it's either we're moving up, down, left, or right. So this is vertically, this is horizontally. So we are going to be using this formula y equals to a into x minus h all squared plus k, where h and k are coordinates of the turning point, remember. So starting with the horizontal shift, this is where we move left or right. So if our h here is positive, remember the horizontal shift is affected by h. If h is positive, meaning this will remain a negative, then the graph will move right. If h becomes negative, now the graph will move to the left, because now it will be plus. Moving on to the vertical shift, if k is positive, the graph will move up. If k is negative, the graph will move downwards. Now we are looking at reflection. So we have two types of reflection. The first one is along the x-axis. So if we are reflecting along the x-axis, remember our axis is like this. These are our x-axis. This is our y-axis. If we are reflecting along the x-axis, meaning we are moving values from this side to this side, the y values are affected. So the y values are going to change sign, right? And then if we are reflecting along the y-axis, which is this axis, we may be moving from this side to this side. Remember, this is the negative side, this is the positive side of the x-axis, and this is the positive side of the y-axis, and this is the negative side of the y-axis. So if we're moving from the negative to the positive, of the x-axis, we are reflecting along the y-axis. So the the x values are affected and the x values change sign.
Also I have the domain and the range. So the domain of any given function is the set of all the x values possible in the function. So in this case, the domain of a quadratic function is all the real numbers unless it's restricted otherwise. And then it is always written in this form unless if it is restricted. So if the domain is not restricted, it always ranges from negative infinity up until positive infinity. Moving forward, we have the range. The range is the set of all the possible y values found in a quadratic function. And then, so the range of a quadratic function, it depends on the vertex or the turning point of the standard formula. So in this case, h and k are the intercepts h is the x-intercept of the turning point of this quadratic function, and k is the y-intercept of this quadratic function. So if the value of a here is greater than 0, the quadratic function open upward, or we can simply say that it's minus, and then it is written in this form: k included up until infinity, positive infinity, k included, which is the y-intercept of the turning point of the quadratic function. If a is less than 0, the function opens downward, or can simply say that it frowns, in which it is written in the form from negative infinity up until to k included. Note that the range of quadratic functions, it can be affected by the restriction of the domain.
Hello, grade 12 learners. So today we are going to deal with question 6, which is a quadratic function. So in this case, you can see that they've given us a diagram of a quadratic graph. So I'll also drew it here. So this is my graph. So in this case, they've given us that our function equation is y is equals to dx minus m squared plus p, right? So we can see that m is an x-intercept and p is what? A y-intercept. So first thing they've asked us is that find m. So m is the what? The x coordinates of a vertex, and we know that the vertex is the midpoint of the two roots, which is the symmetry of the parabola. So in this case, what we'll say m is equals to x1 plus x2 all over 2, which is the midpoint formula. So what do we do next? We'll say, okay, 1 plus 5 equals to all over 2 is equals to 3, because we are using what? The two roots, which is 1 and 5. So our answer is what? 3. So m is equals to 3. Okay, so we're going to continue to what? To P. So P says find P. And the P is a what? It's y coordinate of the vertex. So we can look at the vertex. We can see that the vertex gives us that P is equal to what? 2, because 2, it is the what? The y coordinate of the vertex. So we write that P is equal to 2. So C says find D. Find D. So in this case, if we can look at the equation, you can see this is D. So if we check here, we have to use the what? The intercepts to substitute into the what? The equation. So we are going to substitute 0.1 and 0. We're going to use 0.1 and 0. So first thing which we're going to do is write down the equation, which is squared plus P. So we know that our m is what? 3 squared plus our p is what? 2. So we're going to substitute. Then we know that this is 0. Then x minus what? 3 squared plus 2. So we know that our x is what? Is 1 minus 3 squared plus 2. So therefore, we're going to use algebra. So when it comes, this side is d, then inside it's negative 2 squared. So we know that negative 2 squared is equals to what? 4. So we know that d is equals to negative 1 over